welcome back. Today we're going to talk about radians and degrees. We've already talked about our calculator and how it has to be in radian mode or degree mode, but let's look at what it actually means to have radians. So what is a radian? When we're talking about radians, we're talking about being in a circle. In a circle, the central angle that cuts off an arc that is equal to the length of the radius of the circle has a measure of 1 radian. What does that mean? Well, I'm in the circle, so let's just draw a circle here. And it's a pretty terrible circle, but bear with me. And if the radius is r, so whether it's 1 or 2.5 or pi over 18, whatever it is, it doesn't matter. There's a central angle. We're going to call it theta. We often deal with theta because really when we go into the coordinate plane and we put something in standard position, if it goes all the way around, it forms a circle as it does that 360. And so theta is this angle here. Well, the arc length, we're going to call it S. So this is arc length S. So in a circle, a central angle, theta, that cuts off an arc of length S that's equal to the length of the radius. The circle has a measure of 1 radian. So theta in radians is equal to the arc length over the radius. Think about that for a second. So if it has a measure of 1 radian, then the arc length is equal to the radius. Well, what does that mean? It just means that this is an evaluation of how long the arc is, how big the radius is. That's going to tell us the theta in the middle in radians. That's all there is to it. So when I ask you a question like this, a central angle in a circle has a radius of 3 centimeters and cuts off an arc length of 6 centimeters. We know that theta in radians is equal to arc length over radius is 6 over 3. So theta equals 2. And we can label it radians. This brings me to a notational issue. If theta equals 2, no label. It means radians. If it has the label of degrees, it is degrees, obviously. So let's talk about the situation where, let's say, we have a central angle that goes all the way around. Let's look at this from the standpoint of a circle. If I have this circle here, and I say that it has a radius of r, whatever r happens to be. Let's think for a second. If that angle goes all the way around, well, we know that one full rotation equals 360 degrees. We know that from working in the coordinate plane. Well, one full rotation is also equal to circumference. The circumference, because remember, we're trying to figure out the arc length to find radians, and so the arc length is this measurement around here, the measurement around that circle. Well, all the way around would be length is S, which is equal to circumference. So the S, that arc length, is the circumference because it's all the way around. So 360 degrees in radians is equal to circumference over radius. If we look at this algebraically, how do we calculate the circumference? Well, circumference is pi times diameter over radians, but also it's equal to 2 times pi times radius over radius. Think about that. The diameter is 2 times the radius, so 2 times pi times radius equals diameter. Well, if we do a little bit of algebra, look at what happens. 360 degrees, or all the way around the circle, is equal to 2 pi. That's a really key measurement to remember because that means that everything we have can be based on a fraction of pi. So 2 pi is all the way around. That means halfway is going to be just pi. That means 90 degrees is going to be half of a pi. All right, and so we can start to think about these things in terms of pi and radians and degrees. Think about this. Therefore, we can convert these things. So 1 radian is going to be equal to pi 2 pi over 360 because 1 radian is the length of the arc all the way around over the number of degrees. Well, that's 2 pi over 360, which is equal to pi over 180. I'm sorry, that should be for 1 degree. 1 degree is pi over 180 radians. 1 degree is going to be 180 over pi equals 1 radian. So this is, I just got them backwards, 1 radian. It makes sense because the conversion factor has to do with what we have. If we have radians, we have something in terms of that pi number, well, we're going to have to convert it to degrees. If we have radians, we want to convert it to degrees. We have degrees, we want to convert to radians. The best way is to show it. When we're converting, we want to multiply what we want on top. So if I'm converting to radians, I'm multiplying with the pi on top. So this is going to be 45 times pi over 180 because it's going to give me a fraction of 180 because 180 is halfway around. We could do it 2 pi over 360, but the fraction reduces to that. So this is really going to be 45 pi over 180. And then I reduce the number part. Well, when I reduce that number part, I end up with pi over 4 radians. I want you to do the same thing for 450. Remember, we're going 2 radians, so we multiply by pi over 180. Try that one on your own. When we convert to degrees, we're going to flip that ratio. So if I have pi over 6, and I want to go 2 degrees, I want the 180 on top, because the 180 is the degrees. That's the degrees part. And so you're going to see what happens here. Well, the pi's cancel out. So I have 180 over 6, which gives me 30 degrees. Do the same thing here. Multiply by 180 over pi. So the rules converting. The rules for converting to radians. Multiply by pi over 180. 2 degrees. Multiply by 180 over pi. The general rule is multiply by what you want on top. You want radians? Do the pi stuff on top. You want degrees? Put the 180 stuff on top. That's all there is to it. To do operations with this, we can convert. Well, sine of pi over 6. I don't really know what that is, but I could convert it. So let's see, pi over 6 equals, well, pi over 6 times, and what do I want? Well, I want to go to degrees, so I know I'm going to multiply by 180 over pi, and so that's 30 degrees. Well, the sine of 30 degrees looks like this. Reference angle is 30, so that means this is 1. This is square root of 3. This is 2. So the sine is the opposite over the hypotenuse. It's equal to 1/2. Let's look at this next one. See how easy that was? We're using previous skills to put things together. 4 sine 7 pi over 6. Well, I don't know what this is, so I'm going to convert 7 pi over 6, 2 degrees. And so that's 7 pi over 6 times, and what am I going to? I'm going 2 degrees, so it's 180 over pi. This one's a little more complicated, but the pi's cancel. So I have 7 times 180 over 6. Well, that's really equal to 7 times 180 over 6 would be 30 equals 210 degrees. Let's put it all together. 90, 180. So this is going to be my triangle here. And my reference is going to be 30 degrees because it's 90, 180, 210. So I'd have to go 30 degrees. So this is negative 1 because I'm in that third quadrant. My r is going to be 2. And I'm going to have negative square root 3 here. Well, I'm talking about the sine. So it's going to be opposite over hypotenuse. Sine of 30 in quadrant 3 equals negative 1/2. And I want 4 times that, which is negative 1/2, which gives me negative 2. That's all there is to it, guys. So really all we're doing is converting these radians to degrees and then doing what we've always done. I want you to try this one. So they're going to ask you to substitute a little bit. You're going to have to find a common denominator, but I think you can do it. Thanks for watching. We'll see you next time.